6 and not a 15. Not because we made a mistake, the 15 is correct, but they work with 6 because they do d-mean up here. And it does affect the limiting distribution. What I'm telling you, I mean, you don't have to do those derivations all by yourself, but at least capture some intuitive understanding why those results occur. And I'm repeating, this is not so hard. This simply is a sample average over third powers, but it's still an average, and averages are, under pretty general assumptions, by a central limit theorem, asymptotically normal. The only thing you have to do is to work out the variance, because they are standard normal only upon standardization. But the normality of this guy is pretty clearly ensured by a central limit theorem. And then again, you square. That's why you get a chi-squared with 1 degree of freedom. And that's how you arrive those results. Okay, just encouraging you to not only learn by heart, but understand a little bit more than simply intuitive. That was the message about 7.1. 7.2, someone has estimated, come up with a Waltz statistic. Can you reject at the 5% level? I think that's something you should be able to do. And to make sure that you do it correctly, I do it as well. So we both do it. We talk about 7.2 done by me, 7.2 done by you. And the formulation is kind of weird. Replace the formulation. The formulation says, if you scroll down, what does the Waltz statistic look like? I mean, what I really mean is compute the value of the Waltz statistic. We called it W in our lecture notes, so just look up what W is defined like and use it to come up with a solution. 3. This times we have Heck standard errors, not Heck, but heteroscedasticity robust, Eicher White. Aha, again, Swiss Germany. We do not talk about co-integration, so we take this as a stationary ARDL model. We have trust in the standard errors. We have trust in limiting normality. A, determine a confidence interval. Well, you just saw how we do this. Estimate, standard error, quantile from the normal distribution. A, easy. You do. You should be able to do. B, can you reject the null that beta 1, who is beta 1? Beta 1 is the coefficient associated with Germany, so that's the estimate. That beta 1 is significantly different from 0 at a 5% level. Two-tailed test. Think first, then check. Think only, meaning argue with the confidence interval from A. In B, just cross out this. My idea was probably that you do it twice. Once you argue with a confidence interval. This is what I call think. And then you could compute the T statistic, but there is no point to do that. I mean, only think, don't compute. So you can argue with A to answer B. This is 95, this is 5%. The two questions are immediately related. C, for the null hypothesis that beta 1 is equal to the negative of beta 2, Kretel produces a F statistic. Can you reject the null hypothesis at a certain significance level? Argue with the asymptotic chi-square distribution. How is Wald and F related? How many restrictions do we have here? Which is the correct critical value? These are things you must know. 7.4 mechanical exercise. Beta contains 6 components, and we have a couple of linear restrictions. How many? Second, how does the matrix containing the restrictions row-wise look like? And define the corresponding vector C such that those restrictions are contained in this matrix equation. We did a similar example yesterday, so you just do it again. 5. From a strictly stationary and ergodic moving average process, driven by IID innovations, so the process is ergodic as well, we estimated with 100 observations a sample mean. And we estimated, even if I didn't tell you how, the long-run variance from the data. Determine, once again, a confidence interval for the unknown mean. Well, the solution is kind of obvious how to solve it. There's not only a central limit theorem for martingale difference sequences, there's also a central limit theorem for correlated MA infinity processes. And the long-run variance shows up as the variance in the normal distribution. So you have to standardize the whole thing with the square root of the long-run variance, and then you have a standard normal distribution. And having a standard normal distribution, you can set up your confidence interval. We should all be able to do this. For completeness, I will also provide you with a solution of that. 7.5. So what is missing? Only forecasting is missing. Forecasting we do not rush through now. Forecasting we can solve tomorrow. And maybe we can also solve some of those tomorrow. Well, no, not those. I don't know. Tomorrow we take our time for the mock exam. That's what we start with in the morning. And probably this will take time up to the break, 90 minutes. That's the time you have in the exam as well. And then there is 1 more hour after the break, and we can look at the problem section from chapter 8, and you can ask general questions. So prepare. See you again tomorrow.
Very good.